Hello, kiddos. Today we are going to be verifying some trigonometric identities, and we are going to be doing these in baby steps and phases to help build confidence along the way. So today, the first thing we're going to do is talk about our objective, which is to verify trigonometric identities. So remember, in this unit, I am not grading the answer. It's all about the process. So just keep that in mind as we continue through our problems. So we have a few general approaches for verifying trigonometric identities. So let's talk about the approaches, and then you can hit pause and copy this slide into your notebook. So our first approach is going to be to work with one side at a time. So generally we will choose to work with the more complicated side. It's really up to you, but sometimes working with the simple side does not leave you with a lot of avenues. 2, if you can factor, add fractions, square a binomial, sometimes those are things you will need to do in order to make things look more like the identities on your note card. The third thing is to use those fundamental identities. We printed out a note card with all the fundamental identities on them. The best thing to do is to substitute, simplify, reassess the problem, and keep repeating that process until the left side and the right side of your problem look identical. And really, this is almost my rule number one, but if nothing else works, you should try to convert things to sine and cosine. Those are where our comfort zone is. So if you can make things turn into cosines and sines, a lot of times you will see things from a different perspective, and it will make it easier. And last but not least, you have to try something. If you just sit there and continue to stare at your problem, this is not going to help you get anywhere. Sometimes you'll make a substitution and you will know pretty quickly that it's wrong. Cross it off, try something new. So make sure you're trying something, trial and error. And then also just watch for little things, because sometimes you guys switch tangent and cotangent and you lose signs, so that will impact your problem. So take a minute, hit pause, and copy these approaches into your composition book. All right, welcome back. Let's do some problems together. So problem number 1 is the tangent of x plus the cotangent of x equals secant x times cosecant x. So I am looking at these problems, and I know that I can deal with tangent, cotangent. I also look at the left-hand side where I have two terms, tangent x and cotangent x, and on the right-hand side, I really only have one term. There's no addition or subtraction. So the best way to solve that issue is to find common denominators. So you have two choices here. If you look at that note card, you can use your reciprocal identities and turn tangent into 1 over cotangent, or you can turn both of these into sines and cosines. Today, I think I'll turn both of these into sines and cosines. So I know that tangent x is equal to sine x over cosine x, and I know that cotangent x is equal to cosine of x over sine of x. This side of the problem is going to stay the same. My goal is to make what I'm working with look just like secant x, cosecant x. So now I have two fractions, and I want to combine them into a single fraction. So in order to do that, my common denominator is going to be cosine x sine x. So this is where the process steps from Monday will come into play. We need common denominators. So here you have a cosine x, which is great, but you need a sine x. So I'm going to multiply this side by sine x over sine x. On the right, we have a sine x, but we're missing the cosine x. So over here, I'm going to multiply this side by cosine x over cosine x. So now I need to go through the process of cleaning up my numerator. So sine x times sine x. Remember that we will square the trig function and not the angle. Cosine x times cosine x is cosine squared x. So now you'll have to look at your note card. I see a squared here and I see a squared here. So that really tells me on my note card I might want to look at my Pythagorean identities. And if I look at those Pythagorean identities, there's a Pythagorean identity that says sine squared of x plus cosine squared of x equals 1. So I'm going to take out sine squared x plus cosine squared x and turn this into 1 over cosine x sine x. Because I have a secant and a cosecant in my answer, I'm going to turn this into 1 over cosine x and 1 over sine x, which actually has the equivalent value of the previous step. 1 over cosine is secant x, and 1 over sine is cosecant x. And if you look, that is what I was trying to get. So now this problem is solved. Please remember through this whole process that I am grading your process. Okay, so when I talk about grading your process, I am grading this, not totally the fact that you ended up with secant x. That's really part of the answer. I understand that, but it's all these steps in between is what I'm going to be looking at. All right, let's check out another problem. For example, number 2, we have cotangent to the fourth x times cosecant x equals cotangent squared x, parentheses, cosecant cubed x minus the cosecant of x. So if I look here, I already see things that I have in common. I'm looking here where I have a cotangent to the fourth and a cotangent squared. So I don't really need to get rid of all those cotangents. So I'm going to do something just mathematically equivalent, but I'm just going to change the look of that. I'm going to come in here and I'm going to rewrite this as cotangent squared x times cotangent squared x. Has the same value as cotangent to the fourth x, but I'm just writing it as two separate pieces. And then I have my cosecant x. All right, so now I have a cotangent x on the left, and I have a cotangent squared x, and I have a cotangent squared x on the right. Problem is, the second cotangent right here is an issue. So somehow I need to get rid of that, and I need some more cosecants. So because this is squared, I'm again going to look at my Pythagorean identities and see if one of those identities will help me out. I have an identity that says 1 plus the cotangent squared of u equals the cosecant squared of u. That's not really what I have going on, but if I could get this cotangent squared by itself, then that would really help me. So I'm going to take this one and I'm going to mathematically move it over to the other side. So I know cotangent squared u is cosecant squared u minus 1. So I am going to come to my problem. I'm going to bring down my first cotangent squared x because I need that. I'm going to replace the cotangent squared x with this over here that I just manipulated, and this is cosecant squared x minus 1 times the cosecant of x. Now, remember our goal is to get the left-hand side to look like the right-hand side. So I'm getting close. I have a cotangent squared. I have a minus here, and I have a minus here. But now I need cosecant cubed and a cosecant. However, if I come in and I simply distribute this cosecant here and distribute this cosecant here, that will help my problem. So again, the cotangent squared x needs to come down. Cosecant squared x times cosecant x is cosecant cubed. Bring down my minus sign. And then 1 times cosecant x is cosecant x. And now my left side looks like the right side of my original problem. And that tells me that this problem is now complete. This will get easier, and it's impossible for me to show you every single little quirky thing you're going to run across, but I'm going to do my best. So, all right, example 3. Looks like we have a cofunction identity that should be glaring at you right now with the pi halves minus t. So let's copy the problem. We have cosine t times the secant of pi halves minus t equals the cotangent of t. When you look at these problems, don't automatically think, oh my gosh, how am I going to get from the left to the right? Just take them one step at a time. So in this particular problem, I'm looking right here at this, and this just shouts cofunction identity. So if you look at your note card, you should have a cofunction identity that says something to the effect of the secant of pi halves minus t equals the cosecant of t. So the cosecant of an angle is equal to the secant of its complement. So I'm going to make that substitution real fast. So we have the cosine of t times the cosecant of t. So now I need a cotangent, which I know is cosine over sine. I'm looking right here at this cosecant, and I know by those reciprocal identities that we're getting really good at recognizing that this is 1 over the sine of t. If I multiply these two fractions together, I get the cosine of t over the sine of t. And those quotient identities will tell you that that is going to turn into the cotangent of t. So the right side and the left side are now identical, which means you are now finished with this problem. All right, and the last example for today, we have secant theta minus cosine theta equals sine theta tangent theta. So again, on my left-hand side, I have two terms, and on my right-hand side, I only have one term. So the best way to do that is to take fractions and add them together. I do not have fractions right now, so I'm going to go with the old mojo of taking everything and turning them into sines and cosines. So I'm going to work with the left-hand side. I know that secant is 1 over cosine theta. And now I do have a fraction minus a non-fraction, but I can combine those by finding a common denominator. My common denominator here is cosine theta. I have a cosine theta in my first fraction, so it's all good there. In my second fraction, I need a cosine theta in my denominator. In order to keep values equivalent, I'm going to multiply by the wacky form of 1. So this leads me to my numerator, which is now going to be 1. Bring down the minus sign. Cosine theta times cosine theta is cosine squared theta. So now I'm looking, and I have a 1 minus cosine squared theta. And if I look at my Pythagorean identities, I have a Pythagorean identity that says the sine squared of theta plus the cosine squared theta equals 1. However, I can very easily take this cosine squared theta over here and subtract it. So now I know that that 1 minus cosine squared theta is actually sine squared theta. Always be looking up here at the right side, because sometimes you'll have things you need. So right now I'm looking at the right side and I see this sine theta right here. I'm looking right here and I have a sine theta. So I'm going to pull that sine theta out to the front, which leaves me with sine theta all over cosine theta. I need a tangent theta, but when I look at sine theta over cosine theta, that is tangent theta. So that will give me sine theta times tangent theta.